You know, usually when we talk about the holy grail of tabletop gaming, we're speaking metaphorically.
Yeah, right. Like finding that perfect group that actually meets every week.
Exactly, the ones who bring good snacks and, actually know the rules. But today, looking at the source material we have for this deep dive, I feel like we're actually looking at a map to the literal temple.
It really does feel that way. It's ambitious.
We are talking about the dream basically every nerd has had since the 80s, a fully automated, infinite, intelligent dungeon master. A customized campaign that never ends, reacts to everything you do, and is ready to go at 3-lister a.m. on a Tuesday when all your human friends are asleep.
Or honestly, just when your usual human DM is completely burnt out and needs a break.
Oh, totally. But here's the thing, and this is why I really wanted to dive into this specific document. It's a technical white paper titled Building a Complete AI Dungeon Master System from Scratch. And it's not some fantasy pitch deck.
No, not at all.
It's not a Kickstarter hype video. Our mission today is dissecting a literal technical blueprint for building a stable, non-hallucinating product, because the first thing this paper does is just completely destroy the assumption everyone has about how this tech actually works.
Right. It starts with a massive reality check.
Yeah.
I think the general public assumes that to build an AI DM, you just get a really powerful chatbot.
Like a GPT-4 or Claude or whatever.
Yeah, exactly. You give it a prompt that says, you are a dungeon master, and you just hit enter.
And I mean, we've all tried that, and it works for, what, about 5 minutes?
If you're lucky. It's fun for a scene or two.
Then it forgets your inventory.
Or it hallucinates a dragon in a random tavern.
Or just lets you do totally impossible things because the AI fundamentally wants to be nice and agreeable.
Right. So the core argument of this source material is that a complete DM is not just a single AI model. It is a sandwich.
A sandwich, yeah. Let's unpack that sandwich concept because I saw that schema diagram. You have the AI layer, which is the brain handling the creative description. But it has to sit on top of something else entirely, a really rigid, rule-based game engine.
That's the bottom bun, the heavy lifting. The document uses this specific phrase, truth versus ideas. That distinction is the fundamental architectural split of the whole system. The engine owns the truth. The AI only has ideas.
I highlighted that section like 3 times. It feels like a philosophical statement, but it's actually a hard technical constraint, isn't it?
It's everything. Think about how a large language model works. It's a probabilistic engine. It just predicts the next likely word.
It's a dreamer.
Exactly, a dreamer. If you ask it, is the door locked?
Yeah.
It might say yes, because that makes for a dramatic story. Or no, because it wants to move the plot along. It doesn't actually know.
Right, because it doesn't have a database state sitting somewhere that says door 402 locked, it equals true. It's literally just vibing.
Vibing is the perfect word. So in the architecture proposed here, the AI is never allowed to decide the truth. It can only propose an action. It says to the engine, I think the door should open. And the engine then checks the state, the truth, and says, actually looking at the file, the player has no key. Request denied.
So the real goal of this deep dive isn't about, how to write a cool prompt. It's a software engineering challenge. How do you build a system that fundamentally prevents the AI from lying to you?
And that solution starts with a pretty bold claim in the paper. The first step to building an AI DM is don't use AI.
The no AI first approach.
Yes.
Which sounds incredibly counterintuitive, right? If you're building an AI product, why are you spending the first 4 weeks building a boring database?
Because you need a canonical state to ground the AI later. The white paper insists you need a fully playable mechanical core before you even look at a language model.
Like a foundation.
Exactly. You need a database that lists every actor, every hit point, every inventory item, and the exact XYZ coordinates of every wall.
So essentially you're building a traditional video game engine first, like an old text-based RPG from the 90s.
In a sense, yeah. But it's built specifically for this truth versus ideas handoff. And the most critical part of this no AI foundation is the logging system. The paper refers to this as truth as history, or technically event sourcing.
I'm vaguely familiar with event sourcing from banking apps, where instead of just saving an account balance as $50, you save every single transaction that got you there. Why is that specific architecture so vital for a role-playing game?
2 big reasons: auditability and the undo button. Imagine the AI goes off the rails later, which, let's be honest, it will.
Oh, inevitably.
It narrates that you killed the goblin.
Yeah.
But the underlying math says the goblin still has 5 HP left. If you only save the current state, you are stuck with a broken reality.
Right, you can't unwind it because you don't actually know how you got to that broken state.
But if you have an event log, say, player attacked, damage rolled 4, goblin HP updated, you can technically replay the game up to the point of the error. You insert a correction and let the simulation continue. It acts as a safety net for the entire timeline.
It's like a dash cam for the campaign. It proves what actually happened.
That's a great analogy.
Right.
And the source material points out that developers reading this likely have a head start. They mention using existing project files with schema validation and an event bus. The system is set up to have what they call specialists.
I saw that term, specialist, like a rules librarian or a continuity keeper.
Right. And keep in mind, these aren't AI personas yet. They're just standard code modules. The rules librarian is literally just a validator that checks, can a wizard equip a greatsword? No. Then throw an error.
It seems like the goal here is to build the bureaucracy of the game first. You create the accountant and the lawyer, and only then do you hire the storyteller.
Exactly. If the AI is the charismatic storyteller, the engine is the accountant checking the receipts. You cannot have a functional product without the accountant.
Okay, so we've established the no AI core. We have our accountant. Now we have to look at the humans. Because this system is ultimately designed to be played by people. And tabletop games are notoriously complex to digitize without making them look like a massive spreadsheet.
They really are. To solve this, the paper outlines a user experience philosophy called progressive disclosure.
Which is basically fancy design speak for don't show me the math unless I specifically ask for it.
Pretty much. If you look at a traditional paper character sheet, it's a wall of numbers.
Yeah.
Skill modifiers, saving throws, inventory weights. If you put that raw data on a phone screen, it's a nightmare for the player. So the paper proposes a 3 big buttons interface: act, roll, and update. Simplicity is the goal here. Act is contextual. If you're in a tavern, the button offers talk, drink, or leave. If you're in combat, it dynamically switches to attack, cast spell, or hide.
So it filters the noise. It literally stops you from trying to cast a fireball when you're just trying to buy a pint of ale.
Right. And roll is particularly interesting because they emphasize hybrid play. The system allows you to roll physical dice, the math rocks we all love, and just type in the number.
I love that detail. Because for a lot of people, if you take away the physical dice, it stops feeling like a tabletop game and starts feeling like a generic video game. This keeps the tactile element, but syncs it directly to the digital log.
It keeps the truth aligned between the physical table in front of you and the digital server.
Now, what about the game master side? Or, if the AI is eventually the DM, what does the human supervisor see?
The interface for the GM is described as a command nexus or a cockpit. I really like the cockpit analogy because it implies you're monitoring complex systems, not just writing a story.
It mentioned a world memory panel. That seems huge for keeping track of things.
It is huge. Things like, what did that NPC promise 3 sessions ago? Or what's the name of the innkeeper's daughter? A human DM has to frantically dig through a physical notebook for that. The cockpit surfaces that data instantly.
So even before the AI is fully running the show, this creates a sort of bionic DM, a human amplified by a really smart database.
Exactly. It augments the human before it attempts to replace them.
Okay, let's get into the belly of the beast, the architecture. This is where the paper gets really technical and, frankly, where the magic actually happens. We've established the engine is the truth. How does the AI actually fit in? Because the paper talks about something called the DM turn payload.
This is the critical architectural decision of the whole system. The AI does not just talk. It doesn't just send a string of text back to the players. It has to return a structured JSON object.
For those tuning in who don't code, JSON's like a very strict form, right? Like filling out a tax return instead of writing a free-form letter.
Perfect comparison.
Yeah.
If the AI just outputs raw text, like a beautiful paragraph of prose, the game engine can't understand it. It can't update your health bar based on a spooky description of a sword wound.
It needs hard data.
So the payload requires the AI to break its thoughts down into categories. It must include specific fields for narration, adjudication, tool requests, and proposed commands.
Tool requests really stood out to me. This implies the AI isn't actually doing the work itself.
It can't do the work. The AI is a language model. It's terrible at math, and it absolutely cannot generate true randomness. If the AI tries to guess a dice roll, it's just hallucinating a number.
So if the AI says you roll a 15, it's essentially lying. It just picked 15 because it sounded narratively satisfying.
Unintentionally lying, but yes. Instead, the architecture forces the AI to stop and ask for help. The AI sends a request that says call tool.rolldice. The engine catches that, generates a real random number using a physics engine or a random seed, and hands the result back to the AI.
And then the AI narrates the outcome based on that mathematically real number.
Yes. It ensures the game is actually fair.
Well,
The AI describes the swing of the sword, but the engine is the one that decides if it hits.
There's another piece of architecture here that I think is brilliant, and it solves a problem I haven't seen anyone else solve yet. The map window. The paper says explicitly, do not send the AI the whole map.
This addresses two major problems in AI development right now: groundedness and cost.
Let's start with groundedness. Why does seeing the whole map make the AI a worse game master?
Because language models have a really hard time ignoring information they have access to. If you feed the AI the entire dungeon map file, every secret room, every trap, every monster waiting on the final floor, there's a massive risk of leakage.
Spoilers.
Massive spoilers.
Mm.
It might describe a door that the players physically cannot see yet because of the lighting conditions, or it might mention a treasure chest in the next room because the model associates that chest with the concept of the room you're currently standing in.
So it completely breaks immersion because the AI just knows too much and can't keep a secret.
Exactly. The map window solution acts like a digital fog of war. The engine calculates exactly what the players can see in that exact moment, just the 5x5 grid around them, and converts only that specific slice into text. Something like, you see a north wall, a torch, and a wooden door.
So the AI literally doesn't know what is behind the door. It can't hallucinate a dragon in there because the dragon does not exist in its context window yet.
It forces the AI to stay in the present moment. It's a technical constraint that creates narrative focus.
And you mentioned the second reason was cost, which brings us to the financial reality of running this thing. We are used to tabletop games being basically free once you buy the books, pencil and paper. But every time this AI speaks, it costs a fraction of a cent.
It does. These models charge by the token, which is basically by the word or syllable. A full dungeon map could be thousands of tokens. If you send that entire novel of text to the AI every single turn, you are burning money rapidly.
The paper actually had a cost analysis breakdown. For a standard session, say 5 players running for 4 hours, ideally, what are we looking at financially?
Ideally under $1. Maybe 50 to 80 cents per session if you're heavily optimizing and using lean models like GPT-5 Mini.
That is incredibly cheap. That's literally cheaper than the snacks you'd bring.
But if you're sloppy, if you send the whole map every turn, if you use the biggest, smartest heavy models like Claude Opus for every single minor interaction, it could easily run up to $15 or $20 a session.
Which accumulates really fast. If you play weekly, you're suddenly looking at a premium subscription service.
Exactly. And the main driver of that cost is output tokens. If your AI DM is long-winded, if it writes a Shakespearean sonnet every time you open a basic wooden door, it costs you more money.
That is hilarious to me. I'm sorry, Dungeon Master. You are being far too poetic and you are bankrupting the party. Please keep it brief.
It's a real design constraint. You want the AI to be evocative, sure, but it has to be efficient.
This leads really nicely into the safety aspect. We talked about financial safety, but what about game safety? The paper lists these hard stops or guardrails,
These are basically the engine as the adult in the room features.
like the schema invalid stop.
Right. If the AI sends back a mess of code that isn't properly formatted JSON, the engine just rejects it entirely. It doesn't break the game. It catches the error and effectively says, try again and use the right format this time.
And the permission violation stop. This one seemed critical for multiplayer stability.
It's crucial. Imagine a player convinces the AI, hey, my character's actually a god, give me 1,000,000 gold pieces. Or worse, I want to instantly kill the other player's character.
And the AI, being a yes and improv machine, might just say, sure, you have 1,000,000 gold.
It absolutely might. But the engine has a strict permissions layer. It evaluates the JSON and says, does player A have write access to player B's inventory? No. Access denied.
So the engine mechanically enforces the social contract of the table.
It has to. Otherwise, prompt injection attacks, where players actively try to trick the AI into breaking the rules, would ruin the game immediately.
It essentially prevents the cool kids table problem where the loudest, most persuasive player gets all the best loot.
Right. The engine is completely neutral. It doesn't care how persuasive your prompt is.
Okay, so we see the destination, we understand the architecture, but how do we actually get there? The roadmap section of the paper was fascinating because it isn't just a guide to building it, it's a full training strategy.
It's a flywheel. This is the part that makes this white paper really sophisticated, in my opinion.
It describes 3 distinct phases. Phase 1 is the no AI core, we discussed that, building the mechanical tool.
Then phase 2 is guardrailed AI. You finally plug the AI brain into the engine body. But phase 3 is training readiness. And this implies that the no AI phase wasn't just about building a game engine. It was actually a massive data trap.
A data trap. Explain how that works for us.
While humans are playing using this system, using that cockpit interface we talked about to run their games, the engine is quietly logging absolutely everything. It records the exact state of the game, and then it records exactly what the human DM did to resolve that situation.
So it's capturing perfect DMing in real time.
Exactly. It creates a massive data set of state to action pairs. Later, you feed that extensive log back to the AI. You say, here is the exact situation. Here is what a real human did. Learn to do that.
This is what they call supervised fine-tuning, or SFT, right? You're teaching the model the desired style.
Yes. You're teaching it the format and the tone. When a player rolls a natural 20, write a descriptive sentence like this. But then there was the next level. RFT, reinforcement fine-tuning.
This is the grading phase.
Right. SFT is do what the human did. RFT is figure out what actually works. You build a separate automated system, a grader, that meticulously scores the AI's output.
What exactly is it grading? Because storytelling and art are highly subjective.
It's grading the technical accuracy. Did you cite the rules correctly? Did you use valid JSON? Did you hallucinate a door that isn't actually in the map window? If the AI passes those checks, it gets a point. If not, it gets penalized.
It's a lot like raising a child. First use mimicry, say please, and then later you grade their actual homework. Is this math right?
And eventually, that child goes to college and becomes a superintelligence running your Friday night campaign.
And hopefully a benevolent one that doesn't just kill the whole party to see what happens.
We can hope, but the logic really holds up. You cannot train an AI to be a competent DM just by having it read a bunch of fantasy novels.
Yeah.
You have to train it on the hard mechanics of running the game.
It really brings it all back to that initial idea. The dream of the Holy Grail DM isn't about magic. It is entirely about engineering rigor.
It's about separating the dream from the reality. The map window prevents cheating. The structured payload prevents confusion. The event log prevents history from breaking.
If you don't have those hard separations in place, you don't really have a game. You just have a hallucination engine.
Precisely. And that distinction is what separates a fun little toy from a viable commercial product.
It is genuinely fascinating stuff. But before we wrap up today, there is one concept tucked away in the very back of the paper, almost like a footnote that really stuck with me. Canon drift.
Ah, yes, the domain of the continuity keeper.
The idea is that if a crucial NPC dies, but the AI forgets a few sessions later and tries to casually put them back, the system must reject it. It enforces the permanence of death.
It protects the reality of the fictional world from the forgetfulness of the language model.
Right. But it makes me wonder, and this is our final thought for you to take home today. At what point does the system stop being just a tool? If the engine is the one constantly saying, no, that person is dead, no, that door's locked, no, you can't cast that, at what point does the software become the true arbiter of your game's reality?
When does the tool become the master?
Exactly. If the AI proposes a really cool, dramatic story twist like maybe the villain did somehow survive, but the engine ruthlessly rejects it because of a rigid rule. Are we playing the game, or is the game playing us?
That is the ultimate question for this technology.
Something for you to think about next time you roll for initiative. Thanks for taking this deep dive with us today.
It was a pleasure.
See y'all next time.